In this lecture, we're going to talk about recursive functions. A recursive function is just simply a function that calls itself. Now, that in itself doesn't really mean much. It's the power that we can do or what we can do with it that actually makes this powerful. So let's take a look at a function that calls itself. So first, I'm just going to define a function called func and give it a parameter x. Now, in recursive functions, we have what's known as the base case. So what I'm going to do is I'm going to leave out the base case to show you what happens if we just keep recursing inside of this function. So I'm going to do something that says return func x minus 1. So as you trace this, you can see that every single time that we run the function with a value x, such as 100 right here, it's going to keep executing this. So 100, 99, 98, all the way down to -1, -2, -3, -4. And you'll see that there is a limit that Python puts on us because every single time we need to make a function call, we actually have to store our way back. So return func x minus 1, we can't actually return from the function of x until we know what x minus 1 is being passed into that parameter. So what happens is we go all the way through the depth of this until there's a stopping point. As you can see now, there is no stopping point. There's no condition that says, okay, if x is this value, stop recursing. So as you'll see when we run this, we get maximum recursion depth exceeded. And that's exactly what I was telling you is in this case, well, Python and your resources has a certain maximum recursive depth. And that recursive depth is around 1,000. So what we can do is we can add what's called the base case. When you get here, we stop recursing. That's what the base case is. So what we're going to do is we're going to say if x is less than 0. So if it becomes negative, then we're going to return 0. Okay. Then we're going to change this and we're going to add x plus func x minus 1. So as you can see, what's going to happen is we have x plus func x minus 1. Well, we can't actually do the addition until we know what func x minus 1 is. And as we go back into it, we can see that we don't know what func x minus 1 minus 1 is. And this is what actually gives us our recursive call. So let's see what happens whenever we print this value. So let's go with 10 instead. And notice we get the value 55. Let's make it a little bit smaller so that I can draw it out for you. Let's do 3. And notice we get the value 6. So what's going on here? Let me get my pad real quick so I can draw this out. So what's actually happening is whenever we make a function call, we have to stop what we're doing. We have to go and service that function call and then get a result back. Well, in recursive functions, we don't get the result back until we hit that base case. So as you can see, func3 is going to execute where x is equal to 3. So in this case, 3 is not less than 0. So we're not going to return 0. Instead, we're going to return x, which is 3, plus func2. So this is where func is equal to 3. So that's what we're looking at right here. Well, we can't do 3 plus something until we know what that something is. Func2 is still unestablished because Python hasn't gone out and run func sub 2. So whenever we run func sub 2, that's where x is going to equal 2, and that's going to be 2 plus func 1. Okay, 2 minus 1, so that's x. So that's what's going to happen there. Okay, so now we need to figure out func 1. Sorry, I'm writing on an angle, but that's, I guess, the way this pad works. So where x is equal to 1, we have 1 plus func 0. Okay, and then finally we have func 0, which is 0 plus func minus 1. So whenever we get to func minus 1, it's actually going to have to make this function call. So it makes this function call. It sees that -1 is less than 0, so it returns 0. Okay, now we can actually figure out what func minus 1 is. So this right here gets replaced with 0. Okay, then we return 0 out of this, so this is 0. Now we have 1 plus 0 equals 1. That gets returned back into func 1. So that's 2 plus 1, which is 3. And then that becomes this portion here. So now we have 3 plus 3, and that's what we print out, which is going to be the value 6. Okay, so as you can see with a recursive function, what we're going to do is we have to figure out what func is, func sub 1. Okay, it's a function, so we actually have to execute that function. And notice that we pause func 3 while we're figuring out what func 2 is. Well, because it recurses also in func 2, we pause func 2, we go to func 1 and see what that function is going to do. We do that until we hit the base case. So as you can see, is we're doing a long line. It's almost depth first. We're going all the way into the depth, and then we recurse backwards. As you can see, we went from 3 to 2 to 1 to 0 to -1, and now we're going to go backwards, following up in the same route. So we go from -1 to 0, 0 to 1, 1 to 2, and 2 to 3. So as you can see, right now, this doesn't do much for us because we can actually do this iteratively by using a for loop. However, there are certain data structures in which knowing how to get back the way we came is important. For example, on a tree. So let's take a look at a tree. We'll do a balanced binary tree. So we'll have something that looks like this. Okay, so this is what's called the balanced binary tree. We have binary because there's only two ways we can go, left or right. Balanced because everything on the left-hand side is smaller than everything on the right-hand side. So we'll do 7, 4. Let's do 9. That can't happen. 4, 5, and 6. There we go. 7, 8, and 9. There we go. So this is a balanced binary tree. Everything to the left is smaller than the parent. In this case, 7 is the parent of 4, 5, and 6. Okay. So this is what's going to happen in this balanced binary tree. So this isn't exactly correct because there would actually be values inside of here, but let's see what we're doing. Now, if I wanted to figure out, if I wanted to add all these numbers up together, so 4 plus 5 plus 6 plus 7 plus 8 plus 9, how would I actually do this using this data structure? So in the data structure, we have a left and a right. So in this recursive call, what we'd have, well, we would have to use recursion to do this. So we start at the root. That is what we're given. We only know where the root is, and then it has a left or right. It has a value, a left, and a right. It's almost like a class, and it just has a left and a right. The left and right is itself, is another tree, as you can see here. So as we move left, we're going to hit this tree over here on the left-hand side. And so we have to keep going left until we're done because those are going to be the smallest values that we have. So we're making a decision on whether we want to go left or right. So say we wanted to search for the value 6. Okay, so what we would do is we start at 7. If the value we're looking for is less than what we're currently looking at, we go left. If the value is currently bigger than, we go right. And so what we do is we keep following this down until we keep doing that until we find 6. Now, in that case, we don't actually care about how we get back to the same way we came. However, going back to the original scenario, if I wanted to add all these together, I would actually have to go depth first into all of these. So for example, 7 would have to go to 4. But however, when we reach 4, notice that we only have value, left, and right. Okay. So when we're sitting at 4, how do we get back up to this portion right here? Well, the way we've got it structured, there is no way to do that unless we use recursion. So the reason we use recursion in this case is because we store, and that's why there's a maximum recursion depth, where we restore how we got back. So remember, whenever we went from 3 to 2 to 1 to -1 in that funct example, then after the base case was hit, we went from -1 to 0 to 1 to 2 back to 3. So as you can see in the recursive, we're actually looping back. We're going back the same way we came. So if we made a recursive call to 4, whenever we're done, that would be our base case because there is no left or right. Our base case in this case is whenever there's no more left or right, we then return. So we'd return back here. Okay, and so the next thing we do is we go on the right-hand side. Okay, so we do a 5, that returns us. We go to the right-hand side, that does a 6, it returns us, it returns us, it returns us, and so on and so forth. So recursion in and of itself is not that powerful, that important. It just means we're going to call the same function. Okay, we have a base case, we have a function that we're going to call, and the power in this is everything done before the recursive call is done in sequential order. Everything done after the recursive call is done in the opposite order. So let me show you what I mean by that. Let's take func over here, and we have our base case. And what I'm going to do is I'm going to print before the call a value. Okay, and that value is going to be x. Okay, and what I'm going to do is we're going to say y equals func x minus 1 because I need to print after. So we'll do x plus y, and then we'll say print after. Okay, so as you can see, what's going to happen in here is I print before and I print the value of X. So in the first case, it's going to be 3. So it'll say before 3. And then what we do is we assign Y equal to func X minus 1. Now remember, we can't print the after until func X minus 1 is executed. And you know that func X minus 1 is going to do 2. So 3 minus 1 is 2. Then it's going to do 1, 0, and -1. So we won't see after until we actually get back the same way we came. So let's take a look at what this is going to look like. So as you can see, it says before 3, before 2, before 1, before 0. So we're actually going in sequential order. Notice that we do -1. So we start with 3, we go to 2, we go to 1, we go to 0. However, look at after. Notice that after goes in increasing order. Why? Because we're actually backing out one step at a time. Remember, 0 goes back to 1, 1 goes back to 2, 2 goes back to 3. Now, where is -1? Well, the reason -1 is being printed out is because the base case happens before the print statement, so we don't see -1. So this is the power of recursion. Notice that we're backing out the opposite direction than we came into it. So if we have a statement before the recursive call, it's done in sequential order, the order in which we make the calls. If we have a function call or some sort of operation after the recursive call, like this after right here, you can see it's done in the opposite order. That's how we have after 0, after 1, after 2, after 3. I don't know why I have these in there. I didn't need those. I was going to do format, but there we go. That looks better. So in this case, we can see that before is done before the recursive call, after is done after the recursive call. And this sequence that we have here is the key to recursion, is the key to what we use recursion for. But essentially in this course, all you need to know is this is what recursion is. If you ever find yourself having a data structure or some reason where you need to go back out in reverse order the way you come in, so you need to do a depth first search where you actually look at all the nodes first, you go to the deepest portion, and then you can back your way out, almost like that tree example. That's what recursion is going to be used for. Recursion, it's not forbidden or anything like that, but it's highly discouraged because you can see we have a maximum depth. We have to store how do we get back each time. And so for 1,000 recursive calls, that's 1,000 ways that we have to get back the same way we came. That's why there is a maximum recursive depth in Python. So that's recursion in a nutshell. There's not much to it, but you'll see whenever you get into searching and sorting in different algorithms, it will use recursion. It'll say this is a recursive call. So I just want you to be aware of what recursion is, what are the properties of recursion, and how to use it in certain situations. Thanks for watching.